Today we're talking about the 6 trig functions on the coordinate plane. Here you have a reminder about angles in standard form. If you look at the picture here, we have an angle in standard form with a terminal side R. And that terminal side corresponds to an xy coordinate in the second quadrant. So what we have to do is use that information to help us set up 6 trig functions. Now what I like to do here, I'm not a big memorizer. So what I like to do here is craft a right triangle, with this being my theta, this being my x, this being y, and this being my hypotenuse. So from here, I can remember that sine is O over h, or y over r. Here I can remember that cosine is a over h, or x over r, because this is my adjacent side, and this is my opposite side. I can remember that tangent is O over A, which is O for Y, X for A, and then I can flip those here for the other 3 trig functions. The one key thing here to remember, I'm just going to circle this, kind of important, is that our R, which is our hypotenuse, try to draw that a little nicer, never is going to be 0. We're never going to have that be negative. So when we do the Pythagorean theorem, to get that, if we have to, we are going to take the positive square root. Here's an example in the second quadrant with a terminal side at the point -3, 4. So if I draw, make sure I have my pen. If I draw my right triangle, here's my theta. Theta always goes here around the center part of the coordinate grid. I'll have -3 for my x. I'll have 4 for my y. And what they're really doing here is they're doing the Pythagorean theorem. It's kind of a long word to write, but they're doing -3 squared plus 4 squared and getting 25 and taking the square root of it, which is 5. So now they have an O, opposite side, an A, adjacent side, and an H, a hypotenuse. And what they've done on this slide is they've started to set up the functions. The 6 trig functions. And what they've done, I'm just going to remind myself what this triangle looked like on the previous slide. Here we remember sine as being O over H, which I think is easier. So my O is my y value. Just want to clean that up a little bit. Sorry about that, folks. Which is 4 over my hypotenuse, which is 5. So I could write cosecant now, because cosecant is just the reciprocal. Here they have cosine, which is A over H, which is -3 over 5. And that's the first time we've seen, really a cosine value or something be negative. So the secant value is going to be the reciprocal, and the tangent is O over A. So the cotangent is the reciprocal. And there you have all 6 trig functions for that particular angle that terminates in the second quadrant. Now if we try another one, here we have the point -4, -5. So we're going to be in the so that makes this the adjacent, this the opposite, and we have to use the Pythagorean theorem to get the hypotenuse. So when you square those, you get 16 plus 25, which is 41. So this is the square root of 41. So now we have enough information to do sine of theta, which is O over H. We can do cosecant, which is the reciprocal. We can do cosine, which is A over H. And we can do secant, which is the reciprocal. And we can do tangent, which is O over A, which is positive. So that's interesting. Tangent's positive there. And cotangent is going to be the reciprocal. So that's interesting information, that sine and cosine are both negative here, but tangent is positive. So in the different quadrants, we can determine which trig functions will be positive and which trig functions will be negative, based on are the x's and y's positive or negative. So for example, when x is greater than 0, which is 1 and 4 quadrants, that's where cosine is going to be positive. So if you look at this little graph, this is kind of a visual representation of all 4 quadrants. Here you see the angle measures in radians. This is the range. So the first quadrant ranges from 0 to pi over 2, which is 90 degrees. The second quadrant ranges from 90 to 180, or pi over 2 pi. The third quadrant ranges from 180 to 270, or from pi to 3 pi over 2. And the fourth quadrant ranges from 270 to 360, or 3 pi over 2 to 2 pi. And in this quadrant, the x's are positive, the y's are positive. So in quadrant 1, all of the trig functions are positive, because you will always have a positive divided by a positive. So we say A for all. In the second quadrant, our x's are negative and our y's are positive. So the trig function that is positive here is the one that deals with the y's for the opposite sign. So sine or its reciprocal, cosecant, are positive in the second quadrant, where cosine and tangent are going to be negative, along with their reciprocals. In quadrant 3, we have a negative x and a negative y. So that means, as we saw in that last example, tangent and cotangent are positive, but sine and cosine are negative. And then in the fourth quadrant, we have a positive x and a negative y. So our sine and our tangent are negative, but our cosine is positive. And we have a way of kind of remembering this. Here the sine is positive, here the tangent is positive, and here the cosine is positive. So we travel this way around the quadrants, and we remember A, S, T, C. And one silly way of remembering that is all students take calculus. And the letters denote which trig functions are positive in that quadrant. So if we look at this one, which quadrant do these belong in? So let's talk about a couple of examples. If sine is positive, we could be in the first quadrant or the second quadrant. And if cosine is negative, we're going to be in quadrant 2. If tangent is positive, we could be here or here, but if sine is negative, we're not going to be here, so we're going to be in quadrant 3. And that's how you can tell what quadrant you're talking about.